Today we are learning about product rules. This is lesson 6.2, and we have already talked about some of these. We talked about zero power, where anything raised to the power of zero is one. We talked about when we multiply same bases with exponents that you can add those exponents. We talked about when you divide same bases with exponents, you can subtract them, subtract the exponents. Today, we're going to talk about power of a product. We're going to talk about power of a quotient. And we're going to talk about power of a power. And then the last one, this is negative exponents. And we learned that negative exponents are not allowed. And when we see a negative exponent, we need to either move it to the denominator to make it positive, or if it's in the denominator and it has a negative exponent, move it to the numerator. So let's look at what each of these mean. All right. Product of a power means that when you are multiplying two numbers that are both in parentheses raised to a power, that you will take whatever that power is and distribute it to both terms on the inside of the parenthesis, so that you end up with a to the nth power times b to the nth. Now, one thing I do want to tell you on these, in this chart that I'm using, it looks like they have a decimal here, but really that should be a raised dot showing multiplication. And they do that over here as well. Okay. So just know that's multiplication. Now, we can't do anything further with this because the bases are not the same. So we leave it like that. Now over here, because we're dealing with numbers, we could multiply that out. We know that 2 cubed is 8. And then 6 cubed is, let me see, plugging it in really quick. 36 times 6 is 216. And then on your homework, I would want you to multiply that out even further and get 1,728. And this would be the final answer if you're dealing with numbers. Now, if you're just dealing with variables like this, then this would be your final answer, okay? So that's product of a power. That's actually on page 2 of our notes. Let's go to the next one, power of a quotient. Remember that quotient represents division. And when we talked about power of a product, that was multiplication. So you're multiplying, that's product. You're dividing, that's a quotient. In this situation, it's the same thing. You're taking the exponent on the outside of the parenthesis and you're distributing it to both the numerator and the denominator, so that you will end up with a to the power of n over b to the power of n. And then using numbers, we have 6/5 in parentheses raised to the power of 7. That means that you are going to distribute the 7 to both the numerator and the denominator. Now, these are such big numbers that I'm not going to plug these into the calculator and figure them out. But, you know, on your homework, you would do that. And I do not believe there are any large exponents on the homework that would make it difficult. So just remembering that you are distributing the exponent to both terms. The last one is power of a power. In this case, this power is an exponent. Okay, so like x to the power of 2. We're talking about the exponent. So when you have a term with an exponent or base with an exponent in parentheses, and that is raised to a power, you're actually going to multiply the powers. So up here, we're adding. Right here, we're subtracting. Here, we're just distributing. Here, we're going to be multiplying. So again, the raised dot is in the wrong spot on both of these. So I'm going to change those. But you're just taking the power raised to a power and multiplying those together so that you get a to the power of mn. Here, you have 3 to the power of 4 raised to the power of 2. So you just multiply the 4 and the 2 together, and you get 3 to the power of 8. Okay. So these are the three product rules that we are going to be focusing on in our notes. And the first one that we're going to look at is actually power raised to a power. Okay, so let's look at those. Okay. So right here, you will see several examples, additional examples beyond what is in the chart to look at to see what we're doing. But I think you guys probably get the gist of this. Whenever you have a power raised to a power, you are multiplying those two powers together so that I end up with n to the power of 3 times the power of 7. And that gives you n to the power of 21. And then this would be your final answer. Okay. Example 2 is the same. You're going to take n to the power of 9 raised to the power of 2. You end up with n to the power of 9 times 2. And that equals n to the power of 18. That 18 looks a little funny. All right, let's go down to example 3. We are now introducing negatives. Remember that is just like a -1. So in the end, you'll multiply -1 times whatever you get. In this case, we are just going to distribute the 5 to the 7. So we have -1 times n to the power of 7 times 5. -1 times n to the power of 35. And we do not have to have the -1 there. So I end up with -n to the power of 35. And that's my final answer. Example 4, I put in here because it is going to show up in your homework. And so all we're going to do is we're going to multiply the two r's together. And if you remember, when you multiply variables together, it would be r to the power of 1 times r to the power of 1. Okay. And when you're multiplying, you're actually adding the exponent. So it's r to the power of 1 plus 1. So sometimes we're using multiple rules at one time. And so we have to be very careful. Again, there's a -1 there. So we have -1 times r raised to the power of r times r. This equals -1 times r raised to the power of r squared. And again, you don't need that -1. If you put it there, that's okay. But your final answer will be r to the power of r squared. All right. So that is when you take a power raised to a power, you're going to multiply the exponents. Okay. So that's your first rule. Let's go ahead and go to page 2. We're going to look at the next product rule, which is raising a product to a power. So when it says raising a product to a power, that just means the product is what is being multiplied inside of the parenthesis. So that is considered the product. And then raising this to a power would be raising it to the exponent. Again, there's some examples here if you want to look at them. But let's go ahead and start practicing. So you're going to take the exponent on the outside of the parenthesis. You are going to distribute it to both terms inside of the parenthesis. So you end up with 5 cubed a cubed. But remember, you need to simplify this as far as you can go. And so we are going to simplify 5 cubed. And 5 cubed is 125. So 125 a to the power of 3 would be your final answer. Right. What I would like for you to do right now, based on what we did here and the chart on the back, I would like for you to go ahead and do examples 6, 7, and 8 on your own. Okay. So what I'm going to do is I'm going to pause the video, and when I unpause it, you are going to see the answers. So you may want to pause it right now before you see all the answers, and you have a chance to complete them. So go ahead and work those problems out. Okay, go ahead and check your answers on here. If you got one wrong, check my steps and see where you might have gone wrong, or check my answers. Okay, we're going to go ahead and move on to examples 9 and 10. My numbers are completely messed up on my notes. I go from 13, 14 back to 11 and 12, and it continues that way on the back. So I'll have to fix that, but just know that I recognize I made a mistake there. So when you're dealing with negative numbers, because the -2 is on the inside of the parenthesis, when you distribute the 3, you're going to distribute it to a -2, and it's going to look like this. -2 in parentheses raised to the power of 3, and then c squared times 3. Okay. Now, if you use your calculator, I'm going to show you how to plug this in. You're going to use your parenthesis. So you have to open up your parenthesis, and then you're going to plug in -2. Now remember, don't put in -2. That will not work. You're going to use the negative symbol. So -2, and then you're going to close your parenthesis. So you're going to enter it in just like it's written. And then I'm going to use my caret, and I'm going to raise it to the power of 3, and it tells me that it's -8. Okay. So I end with -8 times c raised to the power of 6. Okay. So go ahead and try example 10. And I'm going to go ahead and do it on the screen, but I want you to try to start that without me, and then check as we go just to make sure you're on the right track. Okay. Okay, go ahead, and I finished. You probably finished before me, but here is the answer. Okay. All right, so the next 4 are not any different than what we've been doing. So I am going to do 13, and then I want you to do 11, 12, and 14 on your own. So I'm going to do, and then, so I'll end up pausing the video. So example 13, I'm going to take the exponent of 2 on the outside of the parenthesis, and I'm going to apply it to the 5, to the 2, and to the 3. So I have 5 squared, x to the power of 2 times 2, y to the power of 3 times 2. Okay, so in this case, 5 squared is 25. X to the power of 2 times 2 is x to the power of 4. And y to the power of 3 times 2 is y to the power of 6. Okay. So you could also probably do 11 at the bottom, which should be 15. This one should be 16. So if you want to try that one. Example 16 is a little different because once you get your final answer, you will take and multiply that coefficient by -1. But right now I'm going to pause the video and let you do 11, 12, 14, and I'm going to add 15. So do all 4 of those. Okay, go ahead and check 11, 12, 14, and 15. Make sure your answers are correct. And if you need to pause the video to check them, go ahead and do that right now. But I'm going to move on to example 16. Okay, in example 16, we have a -1 on the outside of everything. So we would set this one up just like you did example 15, where you had -2 raised to the power of 3. Here we would do -3 in parentheses raised to the power of 3. But in the final answer, you would end up multiplying whatever coefficient you have by that -1. Okay, so here's how I'm going to write it out. I'm going to have -1 out here on the side. And then I'm going to take my exponent of 3 and apply it to everything inside of my parentheses. So I have -3 raised to the power of 3. So the exponent of A is 1. So it's 1 times 3. You could eliminate that and just put 3 if you'd like. And then B to the power of 5 times 3. I'm going to leave my -1. I'm just going to bring it down. So -1 times -3 cubed would be, oops, I keep doing that little, okay, times -27. And then you have A cubed B to the power of 15. So the last step would be to multiply the -1 and the -27. So the final answer is positive 27, A cubed B to the power of 5. Now, if I explain that way too fast, you can pause the video and just take a look at it and kind of process it a bit if you need to. But we're going to go ahead and move on to page 3. On page 3, we're now raising a quotient to a power. So you're taking division. Division is a fraction, and division, same thing. So n divided by d. And we're raising that quotient to a power. The process is the same in that you are distributing the exponent to both the numerator and the denominator. So in this case, we have n to the power of 3 over d to the power of 3. And then that's your final answer right there. Okay. I am going to do 15, and then I'll have you do 14 and 16 on your own. So front office is still in there? Yes, I will. Thank you. When the bell rings. Okay. Thank you. Thank you. So I'm going to distribute the 6 to the exponent of the x and the exponent of the y. So I have x to the power of 4 times 6 over x to the power of 3 times 6. Not x, y, I'm sorry. Okay, so we end up with x to the power of 24, y to the power of 18. I'm going to go ahead and pause the video and have you do 14 and 16, and then we'll come back and check it. Go ahead and check examples 14 and 15 to make sure that you have the right answer. And then I am going to do 17, 18, 19, and let's see, should I be nice or should I be mean? I don't know. I'll either do 21 or 22. We'll see. Okay, so let's go ahead and look at 17. We're going to take the exponent on the outside of the parenthesis, and we're going to apply it to the x and the 3. So when we do that, we get x to the power of 3 over a to the power of 3 times 3. And simplify that. X to the power of 3 over a to the power of 9. So that one wasn't really any different than what you were doing above. But this one is a little bit different. So one of our power rules, if you look on the chart on the first page, 0 power, anything raised to the power of 0 is 1. 7 to the power of 0 is 1. Negative 1,257 raised to the power of 0 is 1. So since this is being raised to the power of 0, I know that the answer is just 1. But let me show you what's happening. You're taking c to the power of 3 times 0 over d to the power of 2 times 0, which equals c to the power of 0 over d to the power of 0. C to the power of 0 is 1. D to the power of 0 is 1. 1 over 1 equals 1. We do not need to do all of that work. You don't have to do that. Anything raised to the power of 0 is 1. So the answer is 1. Okay, let's move to 19. And I am going to take the exponent of 2 on the outside. And the process is the same as what we've been doing. We're just dealing with longer terms, okay? So we're going to apply it to the 3, the m, and the 4. Then we're going to apply it to the 9 and the exponent of 3. So let's write this out. We have 3 squared, m squared, and n to the power of 4 times 2. Anytime you don't have an exponent, then you just apply that exponent straight to the base. We have 9 squared, m to the power of 3 times its raised power of 2. So let's simplify this. 3 to the power of 2 is 9. M to the power of 2 is just m to the power of 2. And then 4 times 2 is 8, so n to the power of 8. Over 9 squared, which is 81. And m to the power of 3 times 2 is m to the power of 6. We are now getting to additional steps, concepts that we learned in lesson 6.1. So if you didn't do that homework yet, then this is just kind of a review. You may have forgotten a little bit, but we can reduce this fraction here. So we can reduce 9 and 81, and it becomes 1 over 9. And we can subtract these exponents. So I'm going to run out of space here, but let me go ahead and simplify this. We have 1 m to the power of 2. Now, because I have the same base in the bottom, we are subtracting exponents. So that follows the quotient of powers right here, where you have the same bases being divided and they both have exponents, and you just subtract the exponents. So that's what I'm doing. I'm going to take m to the power of 2 minus 6. And then I have n to the power of 8 all over 9. I moved this up to subtract it. Now, some of you already know that when you subtract it, it's going to be a negative and you leave it down here. That's fine. But if you don't see that right away, you can follow the steps that I'm doing. So 9 goes on the bottom. Now, if you need to pause the video because you need to think about this, I know that I'm going a little bit quickly, you can do that. All right, I don't really need my 1 here, so I'm going to get rid of it, but I am going to subtract this, and I'm going to bring my work down here. I end up with m to the power of negative 4, n to the power of 8 all over 9. There's a problem here. We cannot have negative exponents. So remember, now we're going and we're following the negative exponent rule. Anytime you have a negative exponent, you move it to the opposite side of the fraction bar. So in this case, you can pretend that there is a 1 here, and you take this and you move it to the bottom. Okay? So that's what we have to do with that m to the negative 4. We have to take this whole term and move it to the bottom. And by moving it to the bottom, the negative on the exponent becomes a positive. So our final answer is n to the power of 8 over 9 m to the power of 4. Make sure your coefficient is in front of your variable. a lot of work. I didn't leave us enough space. Okay. I think I'm going to choose to be mean, and I'm going to do the easy one as an example and see how you can apply everything that we've learned to do this one. So let's take this. Now, when you're working with parentheses and brackets and all that, you always have to work from the inside out. So I'm going to take what is on the inside, which is x to the power of 4 raised to the power of 2, and I'm going to work that out first. And when I do that, I get x to the power of 4 times 2 because I have a power raised to a power. Okay, so then this becomes, I'm going to solve this right here, and it becomes x to the power of 8, and you could put brackets or parentheses here, raised to the power of 3. You know what? Let me rewrite that. Hold on. I don't want to confuse you with the brackets. So we have the brackets, and we have x to the power of 8 raised to the power of 3. And now we're going to take and we're going to multiply these. Brackets and parentheses is all part of grouping, so it's the same idea. We're going to take x to the power of 8 times 3, and we get x to the power of 24. And that is our final answer. So now that we did all that work, let me show you what we actually did. We took 4 times 2 is 8. 8 times 3 is 24. And that's what our exponent is. I am going to have you do example 20 and 22 on your own. Think about in the brackets and parentheses, you're working from the inside out. Work with this first, and then this, and then work with your 3. Okay, you might actually need to combine like terms within the brackets first before you apply the exponent of 3. Okay, so I'm going to pause the video while you work, and when I return, the answer will be up here on the screen. Just try your best. Okay, I clearly did not leave enough space for example 20, so I'm going to try to show you what I did. This was the first thing that I did right here. And then right here. And then, so basically I just applied the exponent. You guys might have just gone straight to this, but I'm showing all my steps. So I ended up with 8, c to the 9th, d to the 15th, over 27, c to the 12th, d to the 24th. Then I went down here. Let me use a different color. I went down here and I subtracted my exponent. So I basically brought my variables up to the top and subtracted them. When I did that, I realized I had c to the -3, d to the -9, and I had to move those down. So I took d to the -9, c to the -3, and I moved it down with my 27. And so then I ended up with this as my final answer. That is not, I wish I had more space. I'll probably make more space on the notes for it. Okay. On example 22, I stopped midway through. I just wanted to make sure that you got this step correct. So after we apply all the exponents on the inside, we end up with x to the 4th, y to the 2nd, x to the 2nd. I smeared that. Hold on. This is x to the 2nd, and then y to the 6th. We have to remember our rules of multiplication with exponents. So going back to our chart, when we multiply with exponents, we're actually adding our exponents. So at this point, we have to take our 2 x's and we're going to add our exponents to them. So x to the 4th plus 2. And then we're going to take our 2 y's and we are going to have y to the 2nd plus 6, all in brackets. And whatever answer we get, we raise to the power of 3. Okay. Adjust this just a little bit. I need more space. So we end up with x to the power of 6, y to the power of 8, and Now we're going to take the exponent of 3 and we finally get to distribute it here. And I'm going to move my answer up here. Our final answer is x to the power of 18, y to the power of 24. All right. So that concludes our lesson for 6.2. If you have any questions at all, please come to help class or email me. And I am more than happy to help.